and happy Friday. We are working on GEMDAS, properties of numbers, and prime factorization today. So all three of those things. Remembering that GEMDAS is just our order of operations. So we have groups, exponents, multiplication, division, addition, and subtraction in that order. Prime factorization is the skill that we practice that looks kind of like a Christmas tree. So if I wanted to find the prime factorization of 24, I would put it in a big star, 24 at the top. And then I'm breaking it down into smaller numbers. So I know, okay, 24 can be made by multiplying 12 times 2. 2 is a prime number. I can't split it up any farther, so I'm going to circle it. It's done. 12 could still be split up, so I could split 12 into 3 times 4, or 6 times 2, either way you wanted to do that. And then I would circle 3 because it's done. I couldn't split it up anymore. 4, I could split up into 2 times 2, and then we're finally done. Once all of the branches of our little Christmas tree have have ornaments on them, they are all circled, then we're done and we can move on. We would write this out by saying 24 equals 3 times 2 times 2 times 2, because we had 1, 2, 3 2's, or 24 equals 3 times 2 to the power of 3, because our exponent there is just counting, okay, I multiplied 2 by itself 3 times. We're going to go ahead and start with this first problem. It says Shay wrote the expression 5 times y plus 2 plus 4 to show the amount of money that 5 friends paid for snacks at a baseball game. Which expression is equivalent to the one that Shay wrote? So with these GEMDAS and prime factorization problems, we see a lot of equivalent questions. Questions like this one asking us, oh, which expression is the same as this one? So we're going to start with our expression, 5 times y plus 2 plus 4. We're going to use our properties of numbers. So looking at this 5 outside of the group, I can use my distributive property to distribute that 5 inside of the group. So when we have 5 or any number right next to parentheses, we know that this is multiplication. So I can multiply, okay, 5 times y plus, because that plus sign's not going anywhere, 5 times 2. And then keep that add 4 at the end. Once we've distributed, we can actually see, oh, wait, J looks exactly like our expression. This next question has, Keith wrote the expression shown to determine the cost in dollars for an upcoming trip. Which expression is equivalent to the one that Keith wrote? So this is yet another equivalency question, a question asking us, oh, which expression looks like this one? For this one, we're actually going to be using GEMDAS, so we're starting again with the expression that we were given. So we're copying the whole thing down to make sure we don't miss any part of it, or copy part of it down incorrectly. So we do want to make sure, like if this says 127.50, we're copying down exactly the same number, because that's where a lot of our mistakes happen, is when we're trying to copy down our work. If you look at your answer choices, we're not solving this problem completely. We're just going to simplify it. We're just trying to make it smaller. We're going to do that just one step at a time. So I'm going to underline the step that I'm working on. But first I need my GEMDAS checklist. So I have my checklist at the top. And I definitely have some groups in this problem, so I'm going to look at my groups first. Because I have 2 groups, I'm going to solve in the problem from left to right. So I'm starting with this group because it came first if I'm just reading the problem. And if I'm subtracting, okay, 127.50 minus 23.50. When I subtract decimals, I have to make sure to line up those decimals. So I'm subtracting, okay, 0 minus 0, 0, 5 minus 5, 0, 7 minus 3, 4, 2 minus 2, 0, and 1 minus nothing is just 1. My decimal in my answer lines up perfectly with the decimals in my numbers. So I get 104. Those zeros can kind of go away because they don't add any value to my number, right? So like 104 with 0 hundredths is the same as 104. Copying the rest of the expression down, 3 times 8650 plus 4. But I'm not quite done with groups yet. I still have this other group. So I'm going to solve this one next. I have 104 plus 3 times 90, 50. And as I'm checking my answer choices, I see, oh, H works perfectly. Very last question. Leon wrote an expression that is equivalent to 30 plus 6 divided by 12. Which expression could be the one that Leon wrote? To solve this one, we're actually going to start by solving the expression we were given to figure out, okay, well, what is this expression saying? Because we're looking at these options, there's a whole lot going on, and they all look like they could be right. So I'm going to solve the expression I was given first. And I'd get 36 divided by 12. When I solve that, I get a final answer of 3. So when y'all go through and solve these, you're solving each expression with respect to GEMDAS. So making sure you're solving multiplication and division left to right. Everything else is on that GEMDAS checklist. And you're looking for which expression has an answer of 3. You're going to answer that one on your Google, Google Classroom, remembering that it is a quiz grade. If you have any questions, you're asking me in small group. If you have any questions on the homework, you're asking, or you're watching those homework help videos at the end of our classwork tab.